So our next speaker for today, he is a CNCF Ambassador, Docker Captain, and a Google developer expert with over half a decade of experience in tech industry. Can I have a huge round of applause for Harsh Manvar, guys? Come on.
Okay, so Kemcha guys is, first of all, tell me how many of you cannot understand Gujarati? કોઈ એવું છે ને જેને ગુજરાતી નથી સમજાતું? અચ્છા, okay. Few people, only 3-4 people are there, but majority always wins, right? So if you can understand this logic, સમજાઈ ગયું ને બધાને guys is? હા બસ, अब ठीक है. Then you can do anything. Whatever you are struggling with JavaScript, Python, anything, you can do anything, guys. You can understand this, then you can understand anything. Okay, so a little bit about me, if you don't know. My name is Harsh Manvar. I'm a GD in cloud, Docker Captain, CNCF Ambassador. And yeah, I've been doing the contributions on the StackOverflow. How many of you are the Kubernetes? How many of you are working on Kubernetes? Only one people? Come on guys, DevOps, SREs, platform engineer, બધા માસિયર ભાઈ કહેવાય. કરો હાથ ઊંચા, કેટલાક છે? DevOps, platform engineering, SREs. How many of you are developers, JavaScript, Python? Okay, few people are there. Don't worry, I have something for everyone. Any mobile developers? Don't worry guys, I have also something for you. Now everyone talking about AI, MLs and everything, so we'll little bit talk about something else. So this is how the today's agenda looks like. We will be talking about the web assemblies. Anyone have idea? Have any idea? What is web assembly? Someone not okay, you have the idea. Okay, don't worry, but still I have something new for you. Don't worry. So we will be discussing what is WebAssembly, how you can use it into the web, how you can use it into Flutter, mobile apps and everything. And then for Amari Biradrina Loco, specifically the DevOps, SREs, platforms, how you can deploy and run the WebAssemblies on GCP. ચાલો ને બધા સાથે તો સ્ટાર્ટ કરવું છે? ડન? ચલો તો કરી દઈએ. Now, what is WebAssembly? કેટલા લોકોને બીક લાગે છે કોડિંગ કરતા, like they don't want to do their careers. If you are a student and they don't want their career into the coding and they want to do the DevOps or something else, cloud engineering or something. આથી જો કરો કેટલા, મને તો 3-4 લોકો પૂછ્યું, હું પછી કહું એના કરતાં ઊંચું કરી. અચ્છા 2-3 લોકો છે. Don't worry. So this is not some language or something. What is WebAssembly? It is a compile target. Now compile target, what basically means that you are writing the code into JavaScript, Python, you are writing into Flutter or anything. You can just convert that code into WebAssembly and you can run it. Now why you need WebAssemblies? That is the main question. Why you need to convert your code when you can run the JavaScript, Pythons and everything? So the idea behind WebAssembly is that you can run to the native speed and it is faster than JavaScript. છે કોઈને કોમ્પિટિશન કરવાની ઈચ્છા હોય તો let me know. Few of the Munstack developers and everyone I know, but when you convert your code, it is WebAssembly is the faster because it is converting your code into the assembly level language, and when the assembly levels comes into the picture, definitely it is the faster than any language, whether it's a Python, JavaScript or anything. Now, as you can see, it is more efficient for security purposes, and mostly it was planned to run the WebAssembly into the browser. Now, generally તમે જોવો ને તો લોકોને આમ ઈચ્છા ના થતી હોય કે ફ્રન્ટ એન્ડ એન્જિનિયર્સ હોય એ લોકો રન કરતા હોય WebAssemblyના બ્રાઉઝરમાં, તો બેક એન્ડ એન્જિનિયરને એમ થયું કે અમારે પણ રન કરવી છે WebAssembly. So this is why the WebAssemblies WSI comes into the picture, that you can convert your backend code also into the WebAssembly. So we'll understand that. Don't worry if you don't have any idea how you can run the WebAssembly into front end, how you can run WebAssembly into backend, and we'll also run the WebAssembly into containers. બધા માટે કંઈક છે. If you are a mobile developers, don't worry. Now it is also platform independent. Once you have created WebAssembly, you can run it anywhere, whether it's a mobile, it's a browser, containers. Regardless of any platform, you can simply run it. Now WASI and WIT, this is two terms that comes into your picture when you start creating the WebAssembly modules. The meaning of WSI is that it is a system interface. Now, system interface means when you are running any code, like suppose you have the binary running of WebAssembly, it cannot directly access your host machine file systems and everything. It is very, very secure when you are running the WebAssembly code, or I would say binaries or anything. At that time, the system interface comes into the picture, and you give the specific access to that code. And then it can able to access the host machine system, file systems, resources, CPUs, memories, and all those things. The next is WIT. The WIT stands for the type. It is more into when microservices you are running. How many of you are running microservices? Come on, only 3 guys running microservices. I don't believe it. Okay, 4 guys, come on, 5, 6, 7, now, okay. So if you are running the microservices and your services are talking to each other, then you need a WIT. Cause how basic example apu tamne. If you are running the Python data type and the JavaScript data type, and you define the variables, બેમાં કઈ difference આવે કે ના આવે? Python's variable define કરો, JavaScriptના variables define કરો. Now તમે બેયની binary બનાવો. Now you are creating the binary of Python, you are creating the binary of JavaScript. You have the different responses, different variables and everything. Now what will happen when both will try to talk to each other? So that is where the WIT comes into the picture, and it helps the WebAssembly how both can interact together, how you can manage the types and everything. So that is what main about these two components, WSI and WIT. This is what the original requirement was there of WebAssembly. The main idea was to only run into the browser. And anyone have used the AutoCAD or Figma, anything? Okay. So all these applications are using WebAssembly. Anyone have used the Adobe Photoshop? The Canva, how many of you are using Canva? Yes, the Canva is completely created on WebAssembly. So that is how they are getting the performance into the browser. You are just thinking it is a very nice software, you are uploading the image and you are doing editing and just exporting. No. The whole engineering is that they are running on the cutting edge technology, they are converting and running the WebAssembly into the browser. When they are running into the browser, they are using your CPUs, memories and all those compute instances. So ultimately, that is using your resources into your computers. That is how it works. And also now Disney is trying to create a development kit so everyone can create and run their code, and you can convert your code and again run your code into the browsers. Shopify's Cloudflare, everyone knows these companies, right? Anyone who don't have idea what Shopify, Cloudflare are doing? So yeah, all these companies are using this. And Freon, that is the company creating the service. So with that service, you will be able to directly deploy the WebAssembly into the serverless architecture on the cloud. DevOps people would be, easy to have the idea how you can, deploy it and create the CI/CDs and everything. To all the developers over here, DevOps engineer, I hope you can get this based on the graph. In 2020s, you can clearly see that the first wave was something about everyone was trying and hyped to use the VMs, that we are deploying onto the VMs and we have the cloud servers and all this. Then the container comes into the picture, everyone talking about containers, oh, we are on Docker. And then the Kubernetes wala. How many of you are certified Kubernetes engineer? Any certified? Okay, looks like okay, no one is certified in Kubernetes, but yeah, most of the people are currently using the Kubernetes. So that is what the current hype was there in 2020s, and then now the WebAssembly comes into the picture. Everyone have heard about the Tesla? Yeah, so that Tesla basically using the WebAssembly into their own car. So what is that? That is one example of IoT, right? Currently, if you just consider it Tesla as IoT, then they are running the small amount of that binary or code or whatever you call it. It is running on the road. It is sending the data to cloud. All your data is stored over there, and then again it is processed by applications and everything. But when you want to run your code efficiently on the edge side, on the endpoint, then you cannot directly zip the Python code, and it is a very bigger, I would say, very bigger release and everything. So that is when this WebAssembly comes into the picture. And you never know, the future will be something like this. Instead of running the container, you all will be running the WebAssemblies directly. Now, how many of you are running Nginx? Anyone have idea what is Nginx? Guys, is Nginx. How many of you are using Nginx? Come on, Apache? Or looks like all the students are sleeping, or they don't have any idea about that Nginx. Okay, thank you. Yeah. So in Nginx there is some limitation. When you start the specific application, you can only run it to the specific port. But there is also something called the Nginx unit. And with Nginx unit, you have the multiple options. You can run and scale the binaries and everything, and you can handle it. So if you don't have any idea, just check out the Nginx unit. That is the new product that they are currently working, developing and all those things. Now, this is the actual means when we say the WASM, it is web plus assembly. You are running the assembly level code into web. And anyone have idea about web GPU? Web GPU. Yeah, so if few people are doing the development, then you can use this web GPU. You can use the resources if your client or your customer have the GPUs running into their systems, you can use those APIs and you can create application that way. So it is more about providing the host API to your code, and your code will be able to use that GPU. It is again, as I explained, it is faster than JavaScript, runs on all the browsers and everything. Don't worry, if you are not understanding it, I have demo also. So we'll focus the demo, Adobe, Figma and everything. Now, as I explained, it is cross-platform. So it is possible if you are running this binary on browser, you can also run it into the mobile application. And I have seen these people have converted their libraries into one binary, and they are running the same logic into the mobile application also. So what it is like, they have the one library with one logic, and they are just using it anywhere, so they don't have to do the double work. You can use it and all these things, IoT devices, I have explained everything, so we are just keeping this one. Okay, so when the WebAssembly joins the club, when you have the requirement of streaming, audio processing, images, video processing, VR, AR, CAD, this is all the use cases and scenarios when the WebAssembly comes in, you can literally get the good performance for your applications. Now, how many of you don't understand HTML? કોને નથી આવડતો? ઓય ગાઈઝ, વાતું કરો, અહીંયા અવાજ આવે, ખરાબ લાગે. હવે તમે મને એ કહો, કેટલાને HTML નથી આવડતો? બધાને આવડે જ છે કે આ વાતું કરે એવું લાગે નથી આવડતી લાગતું? કેટલાને આવડે છે? હાથ ઊંચો કરો તો. અને જેને નથી આવડતું એને બે ત્રણ જણા વૈદા હોય, એ જ વાતું કરે, હાલો કાંઈ વાંધો નહીં, આપણે એને ઇગ્નોર કરી દેવું. So this is what demo looks like. GitHub ઉપર available છે if anyone want to give it try. But okay, ચલો explain. Okay, so this is what I have HTML. જેને સમજાતું ના હોય, અરે નથી ખોલતું. ઓકે, ચાલો અહીંયાથી જ સમજાવી. Okay, this is what I have index.html. બધાને સમજાઈ ગયું what is index.html doing? કાંઈ ના કરે, લોડ થવાની જોઈએ બાય ડિફોલ્ટ, કરેક્ટ? index.html હું HTML કોડ જ જોવાનું છે. Don't ask me what is the logic inside index.html. It is actually loading the JavaScript. You can see it is calling the index.js. Now, before we call the index.js, I have one main.go, and that main.go is doing the what main.go is doing. All the developers, come on. Sum x plus y. Now this is normal main.go file. I don't want to run it. I want to convert it into the WebAssembly binary. Then the instructions are clear. You can use some utility. You can convert it into WebAssembly and you can simply run it. So suppose I converted into the main.wasm. That is what the extension comes. Your code got converted And now if we see the logic of index.js, now inside the index.js, we are clearly loading that WebAssembly file, main.wasm, right? And now this one got things, and if I start the HTTP server over here, and if I run localhost 8080, yeah. So you can see it is giving some additions of number, that is the by default, but you can see the things from the network, so what it is calling basically. So you can see the main.wasm file over there into the down. So it is called by the JavaScript file that was created. So ultimately now you are running the Golang code into your browser. So my question to you is whether you can run the Golang code into browser or not. If you have the simple Golang code, you can run it or not. This is the way you can run it. And as again, it is on browser side, you don't have to much worried about on the server side computations and all these things. So that was the quick demo how WebAssembly runs into front end side. Now, how you can run it on backend. So that is another demo we have. That is the second one. How many of you have, again I ask, most of the people have the idea about containers, right? So this is also one demo, same thing, it is written into the Rust language. All the instructions are clear. You can simply run the Docker run. You can convert again the way I explained, you can convert the binary and you can keep that binary to the Docker and you can simply run it. And you have the option for runtime and platform. These two arguments you have to pass into your Docker build. So these two arguments are introduced by Docker and you can simply utilize to build your container images. Now there is also a third demo, but before we move, this is what we have done till now. We have one code written into the Rust, C language, Python, we are compiling it, and we have the bytecode of WebAssembly, use the JavaScript, HTML to load it, and we simply ran it into the browser. Now let me showcase this one. The third demo that I was more interested. So બે વસ્તુ તો સમજાઈ ગઈ બધાને, the WebAssembly front end side, WebAssembly back end side. Now this is again little bit into AI/ML. Everyone was talking about AI and ML, so I thought why not I? Why not I? So I just written this, and you can see this handsome guy. So it is a machine learning, and you can see the FPS into the corner. How many of you cannot see the FPS? You can see, notice that it is running on the 60 FPS. How many of you have the idea what is 60 FPS? Frame per second. Gamer હશે એ લોકોને તો idea હશે જ, right? So when the frame per second drops, what happens? You guys cried out, right? So this is what the demo looks like, and in corner if you see, it is using the backend as WebAssembly. And you can see, like, if I move around, it is really tracking my head, there is no issue. And now suppose if we change it to WebGL, any developer have idea what is WebGL? It is again the graphics library, you can use it with JavaScript and everything. So suppose I'm trying to create the same demo, my face tracking with WebGL, the JavaScript, and you can see the frame rate dropped to 40. It was running on 60, it got dropped, and now if you see, there is a minor lag you will see when my head is moving. Now suppose if you will be running code onto the CPU, see the FPS, it is running on the 40 FPS, and see the left side. It is the same code. I have not done anything the change into the code, but the main thing changes is the backend. You have the WebAssembly backend, you have WebGL backend, and you have the CPU as a backend. Right. And if I again open and focus into the network tab, and if I simply refresh it, you will see the TF backend WebAssembly files over here. So it is being loaded to the browser. Everyone understand what is happening and what all benefits you can get to converting your code? But it is not again that you can convert all your code unless you are running the heavy lifting applications like audio, videos and everything, then this is something you should consider. Okay, now let's little bit move further. All these services I have listed down over here. everyone have might used it, correct? એક પણ સર્વિસ એવી નથી જે તમે યુઝ ના કરેલી હોય. All these services are using the web assembly into the backend. So let's quickly see the Google Earth. See, you can see the two web assemblies over there. One is the Canvas kit and another is the Earth plugin. So you can see the Canvas kit and whatever plugins are there into Google Earth, it is again written into the WebAssembly. Now this is the one Google photo, everyone have used it into your mobile application, correct? Android users use the photos. This is what I have cooked and I know cooking. So if you notice over here, there is no WebAssembly currently loaded into the network tab, correct? Yes. And if I edit it, it is sending the request and it will open the edit options. I can crop my image and I can do the filters and everything. Okay, looks like my internet is down, but it will load the file. Yeah, so you can see all this file. Now, what I have heard or what I have read, the same logic they have written for Android application for the photo. Everyone are using the Android application. You have the Google Photos into your Android apps. The same logic or same library they have used into the web also. They have not written a new code for a web. This is what I have read. And that is what Google is claiming, that we use the same one. This is what benefit. You don't have to do things. So all the performance and everything, if you even notice the icons and everything, mostly the same only, the load time and everything is less. So that is how the Google is using it. And now we also saw, we saw till now WebAssembly into the browser, but I also show you how you can use it into the containers, and you can also run it into VMs, you can also run it into cloud functions, containers, and everywhere. And you can also run it on whatever you call it, Flutter, Android, or anything. Okay. So now some of you might get questioned, if we have the WebAssembly, then can't we replace the WebAssembly with Docker? You are just bundling your application, you are shifting your binary, then can't we just simply run it? So in future you will be able to do it due to the limitations of WASI, which is more about the interface. Currently you won't be able to utilize all the libraries, the functions, and all the resources are there from the host. You won't be able to do it. So the idea behind that, currently you can do WebAssembly with Docker. So both are together really good fits in. And Docker is also officially supporting the WebAssemblies. So you don't have to much worried about that. There is the support from Docker. You can convert your application to WebAssembly. You can again convert that application into containers, and you can deploy that containers. That is how it works, and it is lightweight. As you know, you are converting into assembly level language code. And this is more architecture of DevOps engineer, Kubernetes, but I can see very less people have idea about how the Kubernetes container works. So I won't be explaining this much, very much. Otherwise, we have the container D, that is the main logic behind the containers, and then you have something called the SIEM. And there are the different types of SIEM. You have the run C options and container process basically managed by the run Cs, and it goes on. Now, if you want to run the WebAssembly, you need a specific type of SIEM. So you can see the WebAssembly edge. So that is one you have to use it, and you can again start using your containers and everything. So very less people are there, so won't be jumping into that things. But there is no meaning if so many developers are there. Now these are the Docker flags that I've been talking about. You have the idea on official Docker documentation also. They have mentioned how they are supporting the WebAssemblies and everything. Now, how many Kubernetes people? Very few or so. Come on, raise the hands once again. Kubernetes, how many of you are using Kubernetes? Okay. How many of you are using GCP? Google Cloud? Only 2 people are using and 500 attending. That's really interesting. But my question, even if you are on any cloud, you are on Azure or any other cloud, you have the Kubernetes service, then can you directly run the WebAssembly containers over there? if you have created into Docker. If you didn't understand the question, let me rephrase it once again. Suppose you have one container created by Docker specifically for the WebAssembly. So you give the two texts, runtime 1 and the platform 1. Due to that, your OS got changed into WebAssembly OS, and you have Kubernetes cluster normal running anywhere, locally or anywhere. Can you run that container image on any Kubernetes cluster or not? Kubernetes expert can answer. Anyone? Okay. No issue. So basically, you cannot do it. In Kubernetes, again, there is, as I explained, there is something called the SIEM, and you need that SIEM to run into worker nodes. And there is no official any cloud that is supporting you to officially give you the worker node that is supporting the SIEM. So you have to edit the worker node, you have to edit the container configuration, you have to edit the SIEM, and you can simply run it. So this is what I'm trying to explain with this architecture. You can edit the container into your existing Kubernetes cluster if you are running on GKE, and you update the configuration files. You have the run WSI. You can take any runtime, you can take any SIEM, integrate it, update the TOML file, restart the service, and you can start running that container images. Otherwise, you will get the error of something OS architecture or something. Now, let me also quickly see. Now we talk a lot. Okay. So the Docker image I was talking about, it is specifically this one. You can see the different OS architecture. You might have seen the OS architecture like Linux, Mac. I don't think you can build the Mac image, but you might have seen the Linux, Windows or something. But this is what the OS architecture looks like. And this is the only reason you cannot run this image directly onto the existing Kubernetes cluster. You have to edit the Kubernetes clusters. But since the audience is very less and less people have the idea about how you can edit the GKE and how you can run it on GKE, so there is no meaning to deep dive into that things and part, how you can utilize the GKE and all these things. But this is what I literally wanted to explain. And yeah, on to all these services of Google and GCP, you can simply run these WebAssemblies anyhow. Again, it is on to you how good you can do the surgery of your code, and you can get the good performance. Yeah, so that's all from my end. I think we have the pretty good time. If anyone have any questions or so. I think, yeah, so that's all. Thank you so much.
Thank you, Manvar. Thank you very much.